Say you're like me and you're bored in your microeconomics class, and so you start drawing graphs and you happen to start wondering how to draw the tangent line to your graph at each point. And it turns out that that's hard because lines are linear and curves are curvy, so you figure it'd be helpful to know the slope of each tangent line that you draw ahead of time before you draw it. So you do a little research and you find out about this thing called a derivative. Taking the derivative of a function f gives you another function f prime that gives you the slope of f at a given value of x. So if you take the derivative of x squared, for example, you end up getting 2x after some math. And that means that if you want to draw a tangent line to x squared at x equals 3, you should draw a line with the slope of 2 times 3. You can also think of a derivative as a function that gives you the rate of change at a point of a function, how much y you get from just a little bit more x, which kind of makes sense given what we already know about slope. So you keep looking up derivatives, and you see a whole bunch of rules, like the chain rule and the log rule. So you decide to just pick the one with the coolest name, which is definitely the power rule, and you learn it, and it turns out that it's actually pretty useful. You find out that the power rule is that for any polynomial function of the form ax to the n, the derivative of ax to the n is n times ax to the n minus 1. So if we wanted to take the derivative of x squared, we can say a equals 1, x equals, well, x, and n equals 2. And so the derivative would be 2 times 1, x to the 2 minus 1, which is just 2x. And if you wanted to take the derivative of 8x to the 6, we can say a equals 8, and x still equals x, and n equals 6. And so the derivative would be 6 times 8, x to the 6 minus 1, which is just 48, x to the 5th. And the derivative of x is just 1, and that also kind of makes sense since the slope of the line y equals x is 1 everywhere. You check back in on your macro class, and you see the words maximization of total revenue in a monopolistic market on the board, and that looks hard, so you zone out and start thinking about the derivative of the total revenue curve. But wait, isn't that just how each additional unit of product sold affects your revenue? That sounds kind of like marginal revenue, doesn't it? You think that's pretty cool and that you may be onto something, so you start playing around with some different equations you remember. You know what the quantity versus price graph for monopoly looks like, and you remember that total revenue is just price times quantity. But we know price can be a function of quantity that looks something like P equals negative MQ plus B. So total revenue is PQ equals Q times negative MQ plus B, which is just negative MQ squared plus BQ. That's what total revenue is. So what's the derivative of that? Well, using our handy power rule, we can find out that the marginal revenue is just going to be negative 2MQ plus B. Whoa! You just proved that the marginal revenue curve is always going to be twice the slope of the demand curve if the demand curve is linear. No matter what. All day, every day. Forever. Go you! Aren't you glad that you did this instead of that boring economic stuff?